Good morning, students. Hope you all are fine. In my last class, I have started with the chapter materials, in which it is related to the topic metals and non-metals. I had discussed about some of the physical properties of metals and non-metals, which metals are soft, which are hard, then what are metalloids. In general, metals are good conductor of heat and electricity. They are hard, they are malleable, they are ductile, and they are generally solids. And except for sodium and potassium, which are soft and they have a low density. They are sonorous also. On the other hand, non-metals, they are non-malleable, non-ductile. They do not conduct electricity except for graphite, which is a good conductor of electricity. And then some metals are solid. Bromine is a liquid non-metal, and some are gases like nitrogen, hydrogen, oxygen. There are some elements which shows both the properties of metals as well as non-metals. They are known as metalloids, like arsenic, silica, and germanium. Now today I will be discussing you with the chemical properties of metal. First, I will discuss about the chemical properties of metal. Today, chemical properties of metal. In this, I will show you the reaction with oxygen. Reaction with oxygen. Now, generally, all the metals combines with oxygen to form metallic oxide. All the metals combines with oxygen to form metallic oxide. Like sodium reacts with oxygen to form sodium oxide. Magnesium reacts with oxygen to form magnesium oxide. So, like sodium, 4Na plus O2, it forms 2Na2. This is sodium oxide. Okay, it is sodium metal. If you keep it in open, it is not kept in open, it is kept in under kerosene oil, sodium and potassium. It reacts at room temperature. Okay, similarly, magnesium, 2 Mg plus O2 gives 2 Mg. Okay, this is magnesium oxide. This is magnesium oxide. This you call it as magnesium oxide. Fine. Similarly, if it reacts with zinc, it will form zinc oxide. Now this magnesium ribbon, you take magnesium ribbon. Now when you heat this magnesium ribbon, it burns with a heat. It is a white dazzling flame. It burns with a white dazzling flame. This one you will do it in practical in your class 9. When you go to class 9, you will do it in practical. Similarly, zinc on strong heating, it forms zinc oxide. Iron on strong heating, very strong heating, it forms ferric oxide. 4Fe plus 3O2, it forms 2Fe2O3. Now this is iron and this is oxygen. This is means 4 iron reacts with 3 oxygen to form. This is called ferric oxide. Ferric oxide, that means or iron free oxide. Okay, my dear students. Now, like similarly copper, if you take copper also reacts to form copper oxide. So, when you go through this metal oxide, they are basic in nature. Generally, metallic oxides are basic in nature. What do you mean by that? They turns the red litmus paper to blue litmus paper. You may not understand now what is red litmus and blue. You will see when you go to class 9, you will read about this. So, what will be the reactivity series? Sodium is maximum, then magnesium, then zinc, then iron, then copper. Like this, the reactivity this is clear to you. Don't worry about this. When I will, after teaching, I will show you how to balance the chemical equation. That topic I will tell you. Now next, coming to the reaction with water. Okay. So metals, they react with water vigorously, okay, under different conditions. Like sodium metal reacts with water to form metal hydroxide and liberates hydrogen gas. The first reaction is sodium plus water. As soon as you put sodium metal in normal water, it will start giving a hissing sound and it will react very fast, forming 2NaOH and liberate hydrogen gas. It will liberate hydrogen gas. So this is sodium metal and it will give sodium hydroxide, my dear students. It will form later. And this will liberate hydrogen gas. This arrow means evolution of gas. Now how can you know that hydrogen gas is liberated? If you bring a burning matchstick, near the test tube, it will give a pop sound. It will make a pop sound, which will indicate that it is hydrogen gas. If you take magnesium, if this water is in this case is cold. If you take magnesium, you have to take magnesium with water. It will form magnesium hydroxide. It will form magnesium hydroxide and liberate hydrogen gas. Okay, it will liberate hydrogen gas, or Mg plus OH2. It will be magnesium hydroxide. It will be hot water, boiling water. Okay, same way it will react with iron. When it will react with iron, when it reacts, you will take red hot iron, Fe. This is red hot. When reacting with water, it will form 3Fe plus 4H2O. It will form Fe3O4 plus 4H2. This is called iron 2,3 oxide. Iron 2,3 oxide, or you can say ferroso-ferric oxide. Ferroso-ferric oxide. Okay, same thing with the liberation of hydrogen gas. Now, if you come to copper, copper does not react. With copper, it does not react. Copper plus water, no reaction. No reaction. So this way. So what is the reactivity series? First is sodium, then magnesium, sodium, then magnesium, then iron, and last is this way the reactivity series. So hope you have understood that sodium, that metals reacts with oxygen to form metal oxide, which is basic in nature, and metal react with water to form metal hydroxide, which and the liberation of hydrogen gas. Now next I will deal with reaction with acids. Now next, reaction with acids. Metal reacts with acids to form metal salt and liberate hydrogen gas. Same reaction. In this, the first one is sodium. The reaction is highly vigorous. Sodium plus hydrochloric acid. This is called as hydrochloric acid. It forms sodium chloride NaCl with liberating hydrogen gas. This is a vigorous reaction. This is a very, very fast reaction. Vigorous reaction. Same thing, if it reacts with magnesium, it will be a rapid reaction. And all these acids are dilute acid. This is a dilute acid. If it reacts with magnesium, Mg plus 2HCl, it forms MgCl2 plus hydrogen gas. This is also a rapid reaction. Third reaction is zinc with hydrochloric acid. At room temperature, it forms moderate reaction. Zinc with hydrochloric acid. Zinc, if it reacts with hydrochloric acid, it forms ZnCl2 plus H2. This is also a vigorous or rapid reaction, a moderate reaction. Same thing with iron. Iron reacts with hydrochloric acid to form iron chloride and liberate hydrogen gas. So, and with copper reacting with HCl, dilute HCl, it does no reaction. No reaction is. So, what is the reactivity series? Same. Sodium maximum, then magnesium, then zinc, then iron, and last is reactivity goes. So, sodium and potassium metal, they are highly reactive metal. Sodium and potassium, they are highly reactive metal, and they are kept under kerosene oil. Because if they are kept out, they will catch fire of their own. So to prevent that, they are kept always inside this one, kerosene oil. Now, reaction of metal with nitric acid is not so much possible because nitric acid is a strong oxidizing agent. HNO3, nitric acid. This is nitric acid, HNO3. This is a nitric acid, which is a strong oxidizing agent. It's a strong oxidizing agent. Okay. So no metals reacts with it because it acts as an oxidizing agent. Certain foodstuffs like citrus fruit, chutneys, pickles are not stored in metal vessels because if they react, they may form harmful or poisonous salt, and which will cause food poisoning or damage to the body. Now coming to the next reaction, reaction with bases and alkali. Reaction with base and alkali. Reaction with base and alkali. Now what is a base? Reaction with base and alkali. What is a base? Towards alkali, you have studied base, you have studied which gives out hydroxyl ion, and all alkalis are bases, but all bases are not alkalis. What are alkalis? Water soluble bases. Water soluble bases are called alkalis. So, if you take, suppose you take sodium zinc metal. Zinc metal, when it reacts with sodium hydroxide, NaOH, what it will form? Na2ZnO2 plus H2. So it will form a salt. And this, what is the name of this? Sodium zincate. Sodium zincate. It will form sodium zincate. Similarly, if it reacts with aluminum, it will form sodium aluminate. And this you have to heat it. This you have to heat this, and this it will give hydrogen gas. So in every reaction, my dear students, you have to, if needed, other than sodium and potassium, you have to provide heat. So one thing I told, metals metal does not react with nitric acid because nitric acid is a strong oxidizing agent. And certain foodstuffs like citrus fruit, dry peel, they are not stored in containers containing metals because they react with acids and forms poisonous salt. So now next, the reaction with bases. Metals like zinc, aluminum, they react with sodium hydroxide to form metal salt and liberate hydrogen gas. And that is like zinc reacting with sodium hydroxide. This is known as sodium hydroxide. The name is sodium hydroxide. You have studied about the elements and some compounds in your class 7. So I am not going to it. I will teach you how to do balancing in the later half of this chapter. Now last reaction is metal displacement reaction. Now what do you mean by metal displacement reaction? A reaction in which a more reactive metal displaces a less reactive metal from its salt solution. A reaction in which a more reactive metal displaces a less reactive metal from its salt solution, that you call it as metal displacement reaction. Like if you take iron, now next is the metal displacement reaction. Metal displacement. That is, if you take iron and you take copper sulfate, iron nails, okay, and you take copper sulfate solution. This is blue in color. You add iron nails and keep it in copper. After some time you will see the color of copper sulfate solution, it turns pale green, and over the iron nail you will see a brown copper deposit. So more reactive metal, iron is more reactive than copper. It displaces copper from copper sulfate and from FeSO. But if you take the reverse reaction, Cu plus FeSO4, it will, no reaction is possible. No reaction is possible. So to discuss about this, it is coming that I will tell you about the reactivity series. Now I will tell you about the reactivity series. So now, what do you mean by reactivity series of metal? The reactivity series of metal is, it is also known as activity series, in which metals are arranged in the order of their decreasing reactivity. That means most reactive metal is at the top and the least reactive metal is at the bottom. So I will give you the chart. First is potassium, then barium, then calcium, then sodium, then magnesium, then aluminium, then zinc, then iron, then nickel, then tin, then lead, and after that it comes hydrogen, and then copper, silver, gold and platinum. This is the reactive metal. The most reactive metal is at the top. Most reactive metal is at the top. This is the potassium. Then barium, then calcium. It is called as, if you name PBCS, you can name it as PBCS Mazintil, MAZINTL. P for potassium, B for barium, C for calcium, S for sodium, M for magnesium, A for aluminium, Z for zinc, I for iron, N for nickel, T for tin, L for lead. In this way, the reactivity series decreases. Lesser reactivity as silver, gold are found in the free state. So all these things, so I told you the reactivity is that is the reason that iron plus copper sulfate, when is the reaction, it forms FeSO4 plus Cu. This reaction is good. But if it is Cu plus FeSO4, then it is no reaction. Similarly, copper plus silver nitrate, AgNO3, 2AgNO3, it forms CuNO3 plus 2Ag. This is silver nitrate, and this is copper nitrate. Okay. But copper nitrate plus silver, it is no reaction. Because you see, copper is here, silver is here. Okay. So silver cannot displace copper from copper, whereas copper can displace silver. So with this, I end up my topic for the day. I will teach you balancing more or less. If you have any doubts, you please ask me in my next class. Thank you, and please copy down all the notes in your copy and make ready your copy for submission, covering it, putting your nameplate, because your copies will be asked for submission to verify. Thank you. May you have a great day.